So we are going to look at this data set. I've just created a 15 students data set where we have their max grade, that is their score in mathematics, the revision hours, the hours they spend revising in a week, and the percentage of the class attendance. So it is believed that once a student revises more and attends almost all classes, he's likely to pass. So we are going to test this hypothesis to see whether it is true or false. That is why you have the score in mathematics as our dependent variable, and these two as the independent variables. So we are going to look at, first of all, the correlation. Then we are going to look at the regression. So we're going to come up with the correlation matrix. To do the correlation matrix, we have just to highlight, you have to come here to data, then go this to where we have this tab for data analysis. If you don't have this tab, it means that you have not installed the plugin. So what you do, just come here to file and go to, I think, options. Then after that you come to add-ins. Just give it some minutes. Then come here and look for data analysis toolpack. You'll see it. Analysis toolpack. Install this one and this one, these two. Then after you are done installing, you restart your Excel and it will appear here. So just click this tab and move up to correlation. Click correlation. Then put range. You highlight all the cells just like that. Then remember to tick here labels on the first row if your first row contains the labels of the different columns. Then you click output range. You want it on a new worksheet, and that worksheet will be named correlation. Then you click OK. You see a new worksheet appears with a correlation. You just click here home, then format, out of it, column length, like that. So this is the correlation. Max grade to revision hours, it is 0.82, and this is 0.88. So once a correlation is greater than 0.75, we say that there is a strong correlation between attending classes and passing mathematics. So if a student attends all classes, he will pass mathematics by 76% chance. The same applies to revising per week. But the more hours you revise, the higher the likelihood of you passing, actually. So this is the correlation. This is the correlation matrix. Then we also need to see how to do a regression analysis. So for the regression analysis, we are going back to our sheet, then come here to data, go to here, look for regression, click OK. So here we have to input the Y range. Move this one. We're going to select, this is our dependent variable, so we are going to put it in the Y, like that. Then we have the X range, the independent variables there here. Okay, we are going to make sure that we have labels and the first column. And for the confidence level, it depends whether you want 95, 99, etc. So let's just put it at 95% confidence level. Then our output, we are going to have a regression on a new worksheet. Just a regression. Then you are going to need, we don't need residuals, you don't need the residual plots, but we can do for align fit. Let's see how this plays out. Then we click OK. Yeah. Yeah, so here we have our regression results. Let me close this one here. Close this one here. So these are visualizations of this. Yeah, we are going to do, as you can see, we have 3 tables, and ignore these ones. This is just the residuals. We use the residuals to test for heteroscedasticity and etc. So since you are not focusing on heteroscedasticity today, this table is just irrelevant for us now. So you're going to focus on these 3 tables. So we have the ANOVA here table. It means analysis of variance. Then you have the coefficients and the standard error table. Then you have the regression statistics. I'm going to explain each of these tables, and eventually we are going to come up with the regression equation, or rather the regression line. So first of all, we are going to start with the first table, where we have the regression statistics. We have this multiple R. It is at 0.315. So this indicates a strong positive correlation between the predictors, that is revision hours per week and percentage of class attendance, and the dependent variable max grade. So a value of 0.8315 suggests that the predictors together explain a significant portion. Actually, they explain a significant portion of variation in max grade. So moving on to R square. R square approximately is at 69.14% if you convert this to percentage. So approximately 69.15% of the variance in mathematics grade is explained by the predictors included in the model. That is revision hours and percentage of class attendance. So the remaining 31% is explained by factors that have not been included in this survey. So this means that the model provides a good fit to the data, explaining a substantial amount of variability in the dependent variable. Then we have the adjusted R square. The adjusted R square takes into account the number of predictors in the model and penalizes for including unnecessary predictors. It suggests that about 64% of the variance in max grade can be explained considering the model's complexity. Then you also look at the standard error. This is the average amount that the actual max grade values deviate from the predicted values by the regression model. It indicates the accuracy of the predictions in the model actually. Then our n here, that is 15 number of observation. You can see from our chart here, we only have 15 variables. So let's go now to the ANOVA table. This we have the degrees of freedom. So degrees of freedom, we call it K. So here K equals to 2. Then here we have n minus 1. Then we have n minus k minus what? Minus 1. Yeah, n minus k minus 1. That is the residuals. The regression, the residuals, and the total of that is the degrees of freedom. So on this table, so the ANOVA table tells the overall significance of the regression model. So here we are focusing more on the significance of F. And this one, the F statistic. So the F statistic at 13.447, and we also have a very low p-value of 0.008626. So they indicate that the regression model as a whole is statistically significant. This is because now the p-value is less than 0.05. If you find that the p-value here is greater than 0.05, you say that we can't trust the results of this regression. But since it is less than 0.05, it means that the results are significant. This means that at least one of the predictors significantly contributes to explaining the variation in max grades. Now we also have the residuals. The residuals are the difference between the observed values of the dependent variable, that is the max grade, and the values predicted by the regression model. There's a residual standard error of 1.89.0201 measures the average magnitudes of the residuals. Then now we have the coefficients here. You have the y-intercept, the coefficient of revision hours per week, the percentage of class attendance there. So for it, actually let me explain it better. For each additional hour spent on revision per week, we expect the max grade to increase by approximately 4.72 points. Although this effect is marginally significant by our P here. Then the percentage of class attendance, the coefficient is at 0.126, this one here. It means there is a very small positive effect on percentage of class attendance on max grade, but it is not statistically significant since it has a P of 0.6495. These are the p-values here. Yeah. Then we now go forward to form a regression equation, or rather a regression line that can be used to predict. So we are going to say that let me merge these cells here. Let me make it somehow beautiful to see. So you are saying that max grade will be equal to first the equation of a line is always y is equals to mx plus c. But now here the predictors are more than one, so we have more than one x value. So let's say y is equals to ax plus bx plus plus c, where now c is the y-intercept. Our intercept is one here. This is our c, this is our a, this is our b. So we are going to say and max grade, normal max grade is our y, so we are going to say max grade is equals to this one, 4.728 multiplied by revision hours hours per week added by 0.1264 multiplied by percentage of class attendance. Yeah, so that is how we calculate correlation and regression using Excel. So remember to like and share and hit the subscription button. But just quickly, if there's someone who is new to regression and correlation, I think we can look at what really is regression and correlation before we go. Yeah, let's just quickly. So you're going to look at regression and correlation. So introduction to regression, just briefly. Regression analysis is a statistical method used to understand the relationship between a dependent variable and one or more independent variables. So its purpose, it helps in predicting the value of the dependent variable based on the values of the independent variable. Like instance for here, predicting students' test score dependent variable based on the number of hours studies. Like here now, in our equation, let me just go back here. In our equation, if we have the hours students spent studying and the percentage of class assistants, we can predict the student's score in mathematics. But that's it won't be accurate percent, but it will be 70% accurate. Okay, based on the revision hours and the percentage of class assistants, we can predict now what the student is likely to score. Then let's go back here, finish just sort of started. So then we look at why regression is important in prediction. Regression is widely used for focusing and predicting future outcomes. It helps understand the trends and patterns within a data. It is used by businesses and researchers to make informed or rather data-driven decisions. Then we look at now introduction to correlation. Correlation is a measure of the strength and direction of the relationship between two variables. That it could be now the grade in maths and hours spent in revision. So a positive correlation shows that both variables move in the same direction. That is, an increase in hours spent studying will reduce to an increase in the percentage of the grade of what an increase in the score in the mathematics test. And also its importance, it helps us understand relationships. It provides insightful analysis. That is how variables relate, and makes it crucial for further analysis and decision making. It's also a basis for further analysis. Correlation analysis serves as preliminary step before conducting more complex analysis like regression. That is why we calculated the correlation first, then we move forward now to regression. So that is it for today. Like, comment, and subscribe. You can also tell me what you think we should discuss next in the comment section. Thank you so much.